For these sample problems, you will need to find the sheet that looks like this, so get that out now. So we're going to fill in this table from your notes together. So the first thing I'm going to do is write the number of electrons along the side for each of the elements. So hydrogen has 1 electron. Helium has 2. Lithium has 3. Boron has 5. Apparently we don't like the number 4. Copper has 6 electrons. Nitrogen has 7. Oxygen 8. Fluorine 9. And neon 10. So what we have up at the top are the first levels in an electron configuration, and if you follow your zigzag rule, you'll know 1s comes first, then 2s, and we'll do practice with that later. But for now, we have to fill the boxes, or the electron shells, or levels, they're sometimes called as, 1 electron at a time. So hydrogen only has 1, so I put 1 arrow in, and the up arrow always goes first, and my electron configuration is 1s. For helium, I put in my up arrow just like I did for hydrogen, and then for the second one, I fill this entire shell and I put in a down arrow. And my electron configuration is 1s2, like that. Lithium, we fill in the up arrow, and then we do the down arrow, but I still need one more, so I put an arrow here. So that electron configuration becomes 1s2, and then it becomes 2s1 because we put 1 arrow in that category. Now we're skipping ahead to boron. So we have our up arrow and our down arrow in 1s. That gives us 2 electrons. Here's number 3, and then number 4, and finally number 5. And our electron configuration will be 1s2, 2s2, and 2p1. Now you don't put the X when you're writing the electron configuration because that just tells you it's the first circle or the first level of 2p. Now remember, P's have 3 levels or 3 boxes. Now with carbon we have 6 electrons, so we fill our first shell and we fill our second shell. Then we move on to P. Now remember how I said P has 3 electron levels. That's why we have 2px, 2py, 2pz. Altogether, they're p. And p can hold up to 6 electrons. So we put our number 5 electron in here, the up way, and then our number 6 electron goes here in the up way. We do all the up arrows of the 2p category first before we do any down arrows. So this electron configuration is going to be 1s2, 2s2, 2p2. And again, you never write the X, Y, or Z in your final electron configuration. That's just splitting it into its 3 levels. So nitrogen's going to look like this. This is not going to change. So that's 4 electrons. Here's number 5, number 6, and number 7. So we have 1s2, 2s2, 2p3. Oxygen's 8, so it's up arrow, down arrow, fill this electron level. So there's number 5, number 6, number 7, and then we start with the down arrows. And our electron configuration will look like this. So the only change is the 2p3 goes to a 2p4. Fluorine, same idea. We fill the first 2 levels like we always do. There's number 5, 6, 7, 8, and 9 that fluorine has. We have 1s2, 2s2, 2p5. And finally, with neon, we're going to be filling our levels like we've done all along. So here's all our up arrows. That gives us 7 electrons. Number 8, number 9, and number 10. And we end up with 1s2, 2s2, and 2p6. Now, when you're asked for an electron configuration, you'll be giving me something that looks like this column. If you're asked for a diagram, that's when you do the arrows in the boxes. So now we've gone on to the next slide that's labeled zigzag rule, and you're going to need your zigzag rule in front of you to help you with this. It's also on the chart or on the slide. So we're going to do the electron configurations for magnesium 12, which means that's its atomic number, so that's how many electrons it has, and Ge 32. Now remember, the S level holds 2, P holds 6, D holds 10, and F holds 14. So we start with 1s2. Then if you look at your zigzag rule, the next one you're going to use is 2s2. After 2s2 comes 2p, and we can put up to 6 in there. And if we add these little numbers on the top, we see we have 10, so we need 2 more electrons to make this electron configuration. So after 2p comes 3s, and we need 2 to make 12 electrons, and that's what you see for your electron configuration. Now we're going to do the same thing with Ge 32. So this time we need 32 electrons. So we start out with 1s2, 2s2, 2p6, 3s2. So what I did was I just wrote down magnesium, and I know I have 12 electrons already. So I need 20 more. So after 3s2, we can see by the zigzag rule, 3p comes next, and it can hold up to 6. So that's 18 electrons. Let me erase that 6 and make it look a little better. And after 3p6, we put 4s, and we can put 2 in there. So now we have 20 electrons. And after 4s, it becomes 3d. And d can hold up to 10, and we're going to put 10 in there. So far I have 10, 20, 30 electrons. And now I need 2 more. So after 3d comes 4p. And we just put in the 2 we need. So that's what the electron configuration looks like for that one. We're looking at the electron configurations of ion examples. We have Cl- and we have Ca2+. So when you're dealing with electron configurations with ions, you always take E away from the highest energy level. Now that doesn't necessarily mean the highest coefficient, but often you'll see that it will. So we're going to start with Cl-. So Cl normally has 17 electrons, so normal is 17 electrons, but because it has a -1, we had to add an electron. So we're writing out an electron configuration for 18. So we start with 1s2, 2s2, 2p6, and that gives me 10. So then I go 3s2, so that's 12, and then I go 3p6, and that's the 18 to give us Cl-. With Ca2+, Ca normally has 20 electrons, and it's obviously lost 2 electrons. So again, we're just doing 18 electrons. So what I like to do is write it out for the 20. Oops, not 2. That should be a 3. And then if I was doing the 20 electrons, I would have a 4s2. Now you can write it like this and then cross that out to show that that's 18. Or you can just write it like the Cl- up above. Both ways are correct. So Fe2+ is normally 26, but it's losing 2 electrons. So we're looking for a total of 24 electrons. But like I said, I like to write it out for the full 26. So I have 1s2, 2s2, 2p6, that's 10, 3s2, 3p6, so that's 18. 4s2 is 20, and 3d6 would give me 26. So that's the normal one. Now in this case, when you're taking away the electrons, you take it from the highest energy level. So that's your 4s2, not your 3d10. So what it's going to look like for Fe2+ is this. And I like you to write it this way so I can see that you knew to take it away from the 4s as opposed to the 3d. So that is how you do Fe2+. If you're doing Fe3+, I start the same way. I write out the 26. because it's going to be 26 minus 3 electrons, so we're going to be looking for 23 this time. So we're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Then we're going to take it away from this one. That takes away 2. And then we're going to take away 1 from this one to take away that third one. So we end up with our Fe3 plus looking like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. That's the first 2 that we took away. And we need to take away 1 more. So this becomes 3d5. So you always want to pick the highest energy level. And then when that one's emptied out, you pick the next highest. And finally, we come to the last slide with sample problems, valence electrons. So we have F9 and we have GE32. So the first thing I'm going to do is just write out their normal electron configuration. So 1s2, 2s2, 2p5 gives me 9 electrons for fluorine. And for GE, I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. I'm going to have to go down low here, I'm running out of room, and 4p2. Now, when you're doing electron configurations, you just choose the electrons of the highest energy level, so the highest coefficient. So we have our regular electron configurations written out, and we want to put the valence. You just pick the highest energy levels or the highest coefficients. So valence for fluorine is 2s2, 2p5. And valence for GE is going to be 4s2, 4p2. And that's how you do valence electrons. So when you're going through these, you need to be sure that you are reading the notes or the slides ahead of the sample problems so you have a little bit of background knowledge so these make sense. And if you have any questions, contact me like usual.